this has been an incredibly busy year in education. We say that every year in education, but this one takes the win on that one. And we are just thrilled that you're here and spending a part of your incredibly valuable time with us today. We hope in exchange we can give you access to something and an overview of something that's going to save some of that time for you, as we know that everybody's working towards meeting the needs of all their students in a sustainable way. And that's why we're excited to talk about ST Math a little bit today and share that with you. A few housekeeping items before we get started. Want to make sure that y'all can see my screen and hear my voice. So just go ahead and raise your hand if you don't mind. That is great. You can go ahead and we got an engaged crew of good listeners. You can go ahead and put your hands down for now. I think we're coming through loud and clear. As we move forward today, this is meant to be an overview of ST Math, but we want to make sure that we're meeting y'all's needs and we're answering the questions of our district folks. So please ask questions, and I will ask. I know we have a chat and a Q&A function on this Zoom webinar. If you can throw your questions into the Q&A, that makes it a whole heck of a lot easier for us to monitor it, respond to it, and then record it so that we can share it back out with other folks so that the questions are answered not just for you, but for everybody. So if you don't mind, please throw the questions that you have into that. We're going to respond directly through the Q&A as we can, as it comes across. There's quite a few folks on this webinar, so we want to make sure that we answer your questions thoroughly and clearly above all, but we will try to answer them in the Q&A as we go. But we will save some time at the end. We have about 10-15 minutes at the end for the kind of overall Q&A that will bring those most asked questions directly to folks. Terry, you asked the question before I could get to it. Excellent job. The recording of the session and the slides and kind of some next steps documents will be on texashomelearning.org as soon as we could possibly get it up. Definitely within the next 24 hours, hopefully by the end of the day today. So very, again, excited to chat with y'all today. We're going to start with a very quick recap of Texas Home Learning. Then we're going to dive into ST Math. ST Math is a supplemental online math program. Through Texas Home Learning, it's available for free for 3 years to any Texan for the K-5. I want to be very clear, for the K-5 ST Math component. Also want to be very clear at this point, this is a supplemental program. This is not meant for you to switch out what you're doing in your core instructional model with mathematics in your district, in your school, in your classroom. This is a supplemental tool that we think makes it quite a bit easier for you to engage students regardless of the location, especially your virtual learners, equip teachers with the data, the information that's going to help you to better meet their needs, but then also give them something that adapts to their individual student learning level and can respond to that. So again, all supplemental. It's not meant to be a replacement of the core math curriculum that you have in your schools and districts. We'll go over what it is, why it works. We get to hear from some friends at Bay City ISD who have been using ST Math, and then we'll leave you with how to sign up and some other next steps if you're not quite ready to sign up, which is totally okay. And then we'll round out with that Q&A. Do want to highlight here, we had a webinar a couple weeks ago right before winter break, and we want to make sure that we made folks aware that this opportunity was out there. There will be quite a bit of information in this webinar that is a repeat of that, but our goal is to go a little bit deeper into the product and then get to talk with some of your colleagues across the state about exactly how they use it. As a recap, Texas Home Learning is an optional aligned suite of resources that are built specifically to respond to this COVID crisis, and is built to respond to the current learning environments that we see across our state. And we're excited to be able to offer a suite of resources that we think are helpful for districts. Those go across professional learning, technology, and instructional materials, which is the focus of our time together today with ST Math. Again, very clear. These are all optional resources that are meant to be helpful for districts and schools and teachers. And if they're not, that's okay. That's okay too. They're completely optional to use. Want to give an overview of the instructional materials released to date. You'll see that many of these are actually core sets of instructional materials. So the ones that are not in yellow, from pre-integrated pre-K all the way to math, science, and RLA are designed to cover and align to 100% of the TEKS. We do have 2 supplemental products that we're excited to share with y'all. One is Amplify Reading Texas, and what's nice about that is you don't have to use the entire Amplify set of instructional materials. You could plug this into whatever core set of instructional materials you're using, and it is designed to be a supplement to that student's instruction. Similar to ST Math, you have full program access to ST Math as a Texan, available to any Texan, public, private, homeschool, a parent. As an individual, you can sign up as well for the K-5 program. So that is what is available, and the focus of our time together today will be specifically with ST Math. Of course, you can always learn more on texashomeLearning.org. That is our hub. You can access the materials, and so you can actually access the ST Math homepage that will show you to that sign up option, as well as view upcoming webinars, see recorded webinars, and then sign up for future updates. I do want to highlight an opportunity that we have this Friday with some office hours with ST Math. You'll see at this link below, this just takes you to the Zoom link to actually register. This information is also up on our website as well. And we'll go ahead and throw that in the chat if one of my colleagues doesn't mind, to make sure that y'all have access to it going forward. So with that, and without further ado, I want to go ahead and turn it over to our friends over at the Mind Institute to talk about ST Math.
Wonderful. Thank you very much, Andrew. I'm just going to share my screen here. Oh, that's probably, seeing my emails is not the greatest thing you've ever seen. All right, fantastic. So we're going to dive into ST Math, and one of the critical things here about the program, it looks very different from other math programs. It's not the same. It doesn't work in the same way. It was designed very differently. And in order to kind of understand that perspective and really kind of get that big picture overview, which is going to be critical as you work with teachers and students with this program, they will sort of need to understand how this works. So we're going to look at it, and we're actually going to look at some of the neuroscience behind the program, because that really helps to understand and put it in context. So I'm going to start with a sort of rhetorical question, one that I had to ask myself a lot about 20 years ago. I began teaching here in the US at Van Nuys Senior High School. I taught mathematics, and I had to ask myself this question a lot: how do we teach? It was something that obviously I'm sure we've all grappled with for many, many years. I grappled with it, sometimes effectively, sometimes less effectively, and eventually hopefully figured some of it out. And then about 10 years ago, in my role then as a district administrator for Los Angeles Unified, I walked into a classroom and I saw something that kind of changed the way that I thought about this question. I realized that someone had asked a subtly different question. Instead of asking, how do we teach? Someone had asked the question, how do we learn? They'd shifted it from a sort of adult-oriented question to a student-oriented question. And what I saw, I walked into a classroom, 42 kids in a computer lab, and I saw that someone had made serious progress in answering that question, how do we learn? I saw kids engaged in problem solving, critical thinking at a level that I had not seen before. All 42 of them in a computer lab, in a school in South Central LA, and they were figuring stuff out. You could hear this kind of chatter going on as they were kind of puzzling, asking questions of each other. And it was very exciting to see. You know that moment, you walk into a room and you can tell learning is happening. And I was excited, I was curious, what on earth is this? I'm looking on the screen, I see a penguin. And I did some digging, and I found out that it was a program that was sort of developed in the late 90s at the University of California, Irvine, and was built on research into spatial temporal reasoning, and decades of research sort of led to this. And it was looking at how that spatial reasoning connects, in fact, to the learning and playing and performance of music, and also, very importantly, how spatial reasoning feeds into learning and understanding math. And the central question that they were really trying to answer was, what if mathematics could be taught in a way that matches the way the brain learns? And the program that was the sort of outgrowing of all of that research was the program ST Math, the ST standing for Spatial Temporal Math. So I found this, I was excited by it. I ended up leaving LAUSD and deciding to come and work to build games with a penguin, which I've been doing for over the last 10 years. So this is interesting. How on earth can we use a game with a penguin to get kids as young as sort of kindergarten into spatial reasoning and then learning math? So obviously, it comes down to games. So here's a game. You can see we've got a penguin on the screen. If I click these buttons, you can see they kind of move the penguin around a little bit. And in fact, if I match the orientation of the penguins, the penguin crosses the screen. The penguin in this case is called Gigi. And the objective of every game is effectively, how can you get Gigi across the screen? So here's a puzzle version of that same sort of manipulative. A couple of things to notice here. You can see here's Gigi kind of on a side, feet poking towards you. And Gigi wants to get across the screen to this orientation here. You can see you have 3 moves to make. The moves are these things across the bottom of the screen. Notice there are no written instructions. There are no verbal instructions. It's purely visual. So this is kind of something that we can get kindergarten students to solve this problem. They wouldn't start here, obviously, but this is something we can do. So let's see who's feeling brave. I know we've got over 200 people on the call. It's wonderful to see you all. Let's see if we can get our collective brain power moving here. So can someone give me a move? Let's have a look. I'm looking over here at my screens. Maybe hold up some fingers. 1, 2, 3, 4, 5, 6. Give me a move. What do we think? What do we see? I'm looking at you guys. Let me see. I want to see some hands. 3. Okay. All right. I see a 3. I'm going to go with a 3. Fantastic. Now notice Gigi did not move yet. This is not because that's wrong. There are actually 12 different ways of solving this problem, by the way, but you have to build the whole sort of construct in your mind. You have to visualize what's going to happen to Gigi with all the moves. So we've done 1, and then we'll see what happens. So what else? We've done 3. What's the next move? 2. All right, let's see. We'll do a 2, 3, 2, and come on, somebody else give me a move. The reason I'm looking here is you guys are all here. So let's see, what else have we got? Someone be brave, step out. I know this is the last move. Come on, we gotta go for it. Give me a hand. Somebody give me
a lot
something
of 5
to
nodules.
a lot of 5. All right, let's try a 5. Here we go. Fantastic. So now let's see whether or not we've got the kindergarten students beat. So, ooh, close. Okay, interesting. Now, notice there was no big red X. I didn't get some sort of like, do you want a hint? Nothing. I just get to try that puzzle again. So let me see. I'm thinking that if I can bring Gigi like this.
Nigel, I'm seeing the same answer come in a lot.
What are you seeing, Garrett?
I'm seeing 2, 3, 3 from Amy, from Marinda, from several others.
Fantastic. Okay, thank you. So let's try that. 2, 3, 3. So we're going to, I need to click the green button. I do need to make Gigi go. So all right, let's see what happens here. Okay, yes. All right, fantastic. Great, you guys are on it. So good. So problem solving, puzzle solving, figuring things out, highly engaging. Now let's look at what's happening in a puzzle like that from the perspective of neuroscience, because this is important. This is really the fundamental crux of what's happening here. And there's something called the perception action cycle. This is not a Mind Research Institute thing. This is not an ST Math thing. This is a sort of, well understood piece of neuroscience that's been around for quite some time. And it's something that all students do. We do this on a daily basis with a million different things. We don't just learn mathematics for it. We build maps of the world around us, everything we do through this perception action cycle. It's a fundamental learning sort of cycle in the brain. So let's have a look at how that works. Anytime we're confronted with a problem, and in this case, the problem we're confronted with is, all right, how do I get this penguin across the screen? We use what we would call our existing schema, our existing neural sort of pathways that we've built, the ideas that we have in our frontal cortex. We use those to make a prediction. Here's what I think will happen. And we make that prediction. In this instance, that's going to say we're going to take some action in the game. The game will then animate out the consequences of that action. And like a lot of you had, here's Gigi going across the screen. Okay, great. Now we perceive the result of that outcome. And here's where it gets interesting from a neuroscience perspective. In the brain, there's a little thing called the hippocampus. It's right, sort of one in each hemisphere, right in the middle. And our prediction, the schema that caused the prediction, kind of sends a signal in one side of the hippocampus, and then our perception comes in the other. So here's what I thought was going to happen. Here's what I see actually happening. And those two things are compared. And in this instance, they matched. What I thought happened actually happened. Boom, they matched. And the hippocampus then sends a signal, literally chemical signal, that makes that schema bigger. It says, wow, next time we're confronted with a similar problem, we're going to use that schema again. Yeah, that worked. This is how we build proportional reasoning schemas, spatial reasoning schemas, numeracy, all of these things. We build these ideas through this repeated action of this perception action cycle. But it's not only when we get something right that we're building schema. So let's just kind of think about that. Let's rewind that a second and go, okay, what happened the first time that we did that? When I made a very different set of moves. Maybe I had some other schema fired up. I chose some different choices here. Again, the game is going to animate out whatever I put into it. But in this case, Gigi did not get across the screen. Again, I perceive that. Same deal, into the hippocampus. Here's what I thought was going to happen. Here's what actually happened. But this time, they do not match. So first up, a signal gets sent to that schema, and it deprioritizes it. It basically says, next time we have that type of problem, let's not use that schema again. This is how we address misconceptions. This is literally how they get sort of deprioritized, like, that idea did not work. I'm not going to use it again. But very importantly, in addition to deprioritizing a schema that got something wrong, the hippocampus sends out something called theta waves, which basically put the brain in a sort of learning state. It says you need to learn something new, and your brain is then actively searching for new information. This is really the sort of fundamental idea behind the work of people like Joe Bowler. This idea that through mistakes, great learning can happen. This is the mechanism, the sort of neuroscience mechanism behind that sort of concept. And it's something that's at play in every single ST Math puzzle. Students will solve thousands of puzzles to get through a grade level of ST Math. So this perception action cycle is building schema all the way as they're moving through that. Something else that's kind of also very much connected to that work of Joe Bowler and a lot of other people is this idea of the importance of visuals in learning mathematics. And there's a very good reason for it. So much of our brains, obviously not everybody, but for most people, so much of our brain is wired into our visual sense. It's one of the fastest ways to get information into the brain. And in that perception action cycle, we need information coming in fast. Language is a very inefficient way to get information into the brain. Language is a brilliant mechanism to get students to talk about what they think they are understanding, to help them deepen their understanding of things. So getting kids to organize their thinking by talking about it is a fantastic use. Language has a big part in the learning process, but getting information into the brain through language is very inefficient. Visuals in math are really powerful for diving into that conceptual piece. So another piece here, it's very tempting, and we see this a lot, and it's something that's been done historically, to think of mathematics as like a list of ideas. You know, textbooks have been organized like this for obviously a long time because we need to put something down on paper. And we've even come to think of math as like, well, here's the list of standards or the list of topics that the kids need to do. And when we're thinking about how do we address learning gaps and so forth, we very often literally go, okay, here's the list of stuff. Here's the stuff you can do. We figured out you can't do these things. This is what we need to remediate, and that will solve the problem. But it doesn't. This is not how the brain actually stores mathematical ideas and information. It doesn't store it as a list. You can't remediate by just picking things from a list and fixing them. The brain stores it in a very different way. So yes, it will have these nodes, if you like these sort of big ideas, like, okay, here are all the ideas from that list. But just as important as the ideas themselves, the way the brain stores the information, the really important piece are the connections between them. It's no exaggeration to say if somebody has a good, deep conceptual understanding of math, literally that means they have tons, millions of connections between all these ideas. They understand how it all hangs together. And that's what we're trying to build for students. This is not going to happen by accident. If you teach just math as a list of ideas, you are not necessarily going to build this deep connected thing. So with ST Math, we are very explicitly trying to build this deep connected conceptual understanding of mathematics. So in sort of K8, for example, or K5, you know, this is kind of the space that we're building and that we want students to understand with a rich web of connections. So we're going to look in a little bit of detail. How do we do that then? How do we do that with a penguin and some games? And let's look in some depth at the topic of fractions, which is obviously a place where a lot of kids struggle. And first up, you'll notice these are some screenshots from different games about fractions. we don't just use one model. We have circular models. Yes, we have rectangular models. We have other shapes. We connect it all to number lines. This is very consistent throughout ST Math. We never ever just use one mechanism to address or learn about a subject. We use all of them and connect them all together. It's critical that students have that sort of explicit connection between all of these ideas. And we're going to look at a specific question and see how ST Math differs in the way that other materials approach specific math problems. So here's a question that was on the NAEP assessment. Estimate the sum 7/8 plus 12/13. Now, this question was on the NAEP assessment. It was also the subject of a paper in the journal Science. And the reason it was the subject of a paper is not because kids did well on this question. Kids did very badly. 8th grade students, 27% of them got it correct. High school seniors, about 35% got it correct. So about 1/3 of kids leaving schools in America were able to get this question correct. And what's fascinating here is, so I've used this question in teacher trainings and used it with kids as well. The minute you put this up, people start cross multiplying, they draw in some crisscrosses, some smiles, they draw butterfly wings or whatever it is that they've learned how to tackle this type of stuff, because the assumption is, oh, this is a fraction addition question. And everybody at some point has been taught how to add fractions. It's not just taught on one day, you didn't just miss it. It's just that very often it's taught as this sort of isolated procedure with no connection to anything else. And in this case, even if you do the procedure correctly, you end up with this. And if you don't understand anything about fractions, if you don't understand, for example, that 7/8 is about 1, you certainly are not going to understand that 187 over 104 is actually about 2, because this question really is not about, can you do a fraction procedure? It's actually asking something much bigger. It's really saying, do you understand the concept of fractions? And unfortunately, from the NAEP assessment data, the answer was pretty clearly not really. In fact, most students were either answering C or D, adding across the top or adding across the bottom. So the question then comes, what do we want students to do when confronted with something like that? What we want them to be able to do is we want them to be able to visualize it. We want them to go, 7/8, yeah, I get it, that's about 1. 12/13, that's about 1. 1 plus 1 is kind of 2, so that's the answer here. So how do we do that with a game with a penguin? So here's a game. Looks very different from the game that we played earlier, but you can see Gigi is still here. And let's say I'm looking at this and I have no idea what I'm going to do. I'm like, okay, I don't get it. I see I've got these balloons. I can drag the balloons. Okay, great. So I'm going to drag these. I'm just going to plonk them down here. Okay, and the green button kind of turned on. So now I can click and see what happens. So, okay. I saw that Gigi kind of got to 1. So maybe Gigi's supposed to get to the balloons. Let's see what happens. All right. I think I'm getting it. The objective here is I need to get Gigi to the basket. So here's where my perception action cycle is going to start kicking in and go, okay, I got it. There was 1 wheel and Gigi got to 1. I kind of see this number line happening here. Now Gigi is sitting on top of 5 wheels. I'm going to make a prediction. You know, I'm going to predict that Gigi's going to get to 5. And again, I get to test that out. I've made a prediction. My sort of hippocampus is eagerly waiting for this information to come to it. And now my perception is going, yep, those things match. Okay, I get what's happening in this game. Notice, even though this game is about fractions, it starts at a very, very straightforward level. Now, I hasten to add, we're going to look at 12 puzzles, kind of in a ramp here. Students would not see these 12 puzzles this close back to back. They would spend a lot more time at each level. We're kind of specifically looking at a, teacher's bird's eye view, here's the learning path kind of a thing. So just want to make sure that that's clear. Okay, so now you can see Gigi sitting on top of a wheel. It's not even a full wheel. We don't need to know that this is half at this point in time, but we can go, okay, I get it. I can see that that Gigi's maybe going to get somewhere here. We can ask questions now where, okay, I see I've got a tiny little bit of wheel. Okay, I'm starting to get how this works. Great. And now something's changed. Can somebody tell me, maybe you can type it in the chat and Garrett can tell me, what's changed? What's different about the way that this puzzle is presented than the way that the last set of puzzles were presented? Garrett, I don't know if you're seeing anything.
I'm seeing numbers show up. There's a fraction instead of a picture. There's a numerical representation. People are
Fabulous.
keyed into
Perfect.
the differences here.
There you go. Awesome.
Coming in fast.
So this is something that we do consistently in ST Math. You'll notice those first problems were completely solvable, purely visually. We didn't even need any symbols, nothing. But now, that's not the case. Now we've transitioned and now we're using symbols. Now we'll see in a moment, very specifically a game where we connect visuals to symbols with fractions. It just happens in a slightly different arena, but we'll look at that in a moment. But now you can see, I now have to understand what these symbols are going to turn into in order to solve this problem. So, okay, we get it. We're going to take a unit, we break it into 3 parts. So here we go. Gigi's going to get to 1/3. Now Gigi's going to get to 3/4. So you start to see now how basically we're graphing fractions on a number line. It's a powerful thing to be able to do. We're connecting the visual models. Now something has changed again. I can't click the basket. What do you think? What do you think we're being asked to do here? Because I can't solve this in the same way. I'm trying to drag, but the basket is not clickable. Garrett, I don't know if you've got any thoughts coming from.
Well, one person wants to know where Gigi is, and
great. Yeah,
someone else
excellent
is
question.
saying,
Yes.
do you click how many circles you'll need?
Okay.
Someone's
All right.
saying to compare the height of the circles to where the basket is. So.
Ooh, interesting. Now that actually, you know, I could so happily dive down mathematically where that's going. I'm not going to do that in the interest of time, because that's actually a really interesting question, because you're really talking now the difference between these diameters and the semicircle circumference. But so these are going to unroll. And somebody was asking, you know, do we need to choose the number of wheels? So the interesting thing here, we can just try it. If we're wrong, we're wrong. So, but basically, this is something we do in ST Math all the time. We get students used to answering questions sort of in one direction, like, okay, get Gigi to the basket. And now we're asking it the other way around. The basket is fixed. How many of these halves do I need to get to 2.5? And I'm going to get it right in the interest of time. And you see Gigi pop back in. And okay, great. Again, we can do that symbolically. How many thirds do I need to get to here? A little bit bigger than 1, 4/3. So we can graph 4/3 on the number line. And again, now we're going to sort of relatively rapidly move up the complexity. We've got a whole bunch of 8s we're going to add together. And now we're getting in a position where we could add fractions together. So we've got 1/3, we've got 2/3. That's going to make 3/3. It's going to get me to 1. Now, again, like I said, students would get lots of puzzles at each kind of step here. We're kind of doing here's the learning path version. But now we're in a position where students can add fractions with different denominators. They don't have to, in this model, they don't have to use a procedure to do denominators. They do that in other games, but this is about estimation on the number line. So here we've got 1/2. We know what that looks like. We know what 3/4 looks like. We can put that together and we know Gigi's going to get somewhere about here. And now we've come to the point where actually we could get students to meaningfully tackle, estimate the sum of these two fractions. 7/8 is going to be about 1, 12/13 is going to be about 1. If I put them together, it's going to be about 2. So I know that was fast, but hopefully that gives you a little bit of perspective about how we can use basically games with a penguin to build very deep conceptual understanding. And what I want to do is I want to take, you know, ST Math is not a couple of cute apps. It's not like, oh yeah, we've got some interesting fraction games. It's a supplemental curriculum, but it's a, you know, very specifically designed and comprehensive curriculum. So for example, here's 3rd grade. Here are all the objectives in 3rd grade. There's 25 of them. We're going to look at the fraction ones in a little bit of detail. They're aligned to the TEKS and so forth and so on. We're going to dig into this fractions concepts objective in a little bit of depth, just so you can see just kind of the scope of the way that we design this. Now, this is the teacher view of that objective. The student does not see all of this text. They just are solving problems and solving puzzles. For us, this is all about intrinsic motivation. There are no badges for students. They don't get to change the background or build an avatar. They solve problems. We build this in a way that they start to love learning. That's the objective here, to work with their intrinsic motivation. Okay, a couple of big deals to notice. One objective, there are 25 of them in 3rd grade. Students solve over 200 puzzles just to get through this one objective. And like I said, if you do the math, that comes out of, many thousands of puzzles to get through one grade level. That's a lot of learning. Key ideas: every single objective is going to have a pre-quiz and a post-quiz. And those questions are going to be very much typical standardized test type questions. We are checking for transfer. We want to know. We're having the students learn through these very visual methods and so forth and so on. Are they transferring that onto typical standardized test questions? And those standardized test questions are available in English and in Spanish. So whichever is most appropriate, that can be, the teacher can choose which language to have those assessments given in as they go through the program. So a couple of other things to notice. In this objective, there are 8 games. Each game has multiple levels. You can see, for example, this first game here has got 3 levels. Each level is going to have 6 or 8 puzzles, depends on the game. And here's how this works. This is a mastery-based program. So a student might race through level 1, and then on level 2, you've already seen if they get a problem wrong, they get that problem again, they get to try it again. But if they get something wrong twice, it bounces them out of the level, and then they come back into it. But we randomly generate the puzzles that make up that level. And we will do that again and again and again. So if they're struggling somewhere, effectively, we adapt by randomly generating as many puzzles as that student needs to sort of figure out and build their understanding of this topic. And we'll come back a little bit to that later on in terms of how that works, especially with teachers monitoring students as they're going through. So notice I've got screenshots of some of the games here for each of these sort of games as we go through. We start fractions concepts with the most fundamental concept of all for fractions, this idea that if you're breaking something into multiple parts, the parts have to be equal. If students don't have that idea solidly in them when they start fractions, it causes all kinds of problems later on. So this is the level that we kind of go to here. So make sure everything's equal. Then they have a game where they have to make things equal. At the end of the day, this is very much about hands-on learning. Then there's a game where they're balancing halves and wholes and stuff like that. Another game where they're balancing fractional parts called Pie Monster. And when they correctly balance the 2 monsters in terms of how much they're eating, they turn around, breathe fire, and kids love it because then Gigi gets to cross the screen. All right, now we have a game called Match Fraction. And I'm going to dig into this one a little bit because it's really critical. This is kind of like I promised a few moments ago. This is one of those games, and there are many throughout the curriculum, but this is one of them where we really explicitly connect visuals and symbols together. This also kind of shows you really clearly, kind of from a design perspective, really what is ST Math, what's it about. So you can see here, we've got a symbolic prompt. We're given 2/5. And what we have is basically a virtual manipulative. That's what ST Math is. It's really virtual manipulatives encased in a game-based shell. And students now need to use this virtual manipulative to build 2/5. Now notice as I drag this to the left, it splits it into an increasing number of parts. So every time I get to the unit fraction, it splits it into that many parts. Very different from how a lot of people build manipulatives. Ours are always 100% mathematically accurate. We go to great lengths to think about how these things work. So I'm going to split this into fifths, and then obviously I'm going to take 2 of them. So students will do tons of this. They will build tons of fractions. They will really clearly understand how fractions work, how the symbols work, how that works with the visuals and so forth and so on. So very important game, Match Fraction. And then, here, for example, you can see, like I was saying, we don't just have circular models or rectangular models. Any shape where you've got similar area pieces is valid for talking about fractional parts. So here we've got some weird fan shape. That's a perfectly good thing to think about fractions in terms of. And then as we go through and end up this one objective, we end up where the student should be able to look at any visual model of a fraction, and they should be able to describe it in numbers. So that just gives you an example of what the depth that we go to in one objective in ST Math. Okay. So it's taking a little bit of a step back and sort of thinking about, so what does this really mean? You might be familiar with a chart like this. You might have called them Quadrant D charts or rigor relevance charts. I've seen them called different things. And it's a good way of analyzing curriculum materials or math tasks or things that you might see in a classroom. Years ago, when I was at LAUSD, I spent a lot of time working with Dr. Uri Treisman and the Dana project in Austin. We did a lot of our PD with them. And we used things like this, to analyze the math tasks that we were trying to get teachers to implement in the curriculum. And, you can think about what type of thinking are the students having to do to solve this? Is this kind of regurgitation of knowledge? Are they memorizing stuff, or do they have to use creative thinking to solve problems? Similarly, when you're thinking about, are these problems that they're being asked to do, are they routine? Like, is it like a worksheet where it's like, okay, here's an example, now solve 25 more? Or are they being asked to solve non-routine problems? And obviously what we want is we want kids spending a lot of time up in Quadrant D, right? Where they're having to use creative thinking, critical thinking to solve non-routine problems. But that's a challenge. It's a challenge for multiple reasons. One, virtually all curriculum materials fall pretty solidly down here. Not all of them, some are definitely written specifically to target this. Obviously the work of people like Joe Bowler very much is about getting materials to teachers that work up here. But it's difficult for teachers to teach here. This is a real challenge. It's not easy to do by any stretch of the imagination. So materials often fall down here, and kids do need to spend some time doing this stuff, but we have to get them up here. And one of the, I think, things that ST Math does so successfully, we can, for all students, without the barrier of language, we can get them solving problems up in this space. One of the big challenges is that most materials, the only way they know how to get kids into this space is through some kind of word problem. And that in and as of itself means that for many kids, they never really get to do the thinking that's at this space. We're able to get all kids doing the problem solving in this space and then add the symbols and add the words on top of that problem solving that they're doing. Once students have a schema, it's so much easier to attach symbols and language to schema that students have, as opposed to the other way around, where you kind of like try and pre-teach vocabulary, but students don't have any idea of what it means, and it just kind of disappears. So that kind of gives you some kind of idea of kind of really what we're able to do with ST Math and why it's proven so successful. And in terms of that success, we have a lot of data. We will obviously happily share. We have tons of data, large scale studies. This one was actually done in Texas from Colleen, I think. And what's fascinating about this is we have, many that are broken out similarly, but when we look at the subgroups, and again, this is data from state standardized tests, not just on, how do they do on ST Math tests. We want to know, how is this teaching methodology transferring to learning on state tests? And we see phenomenal gains in all subgroups. So for example, for gifted kids, yeah, this is awesome. They love it. They can move at their own pace. They get challenging problems. They get to think about math in ways that they probably haven't done before, consistently, day after day after day. But also for special education students, I mean, this is huge. This is a massive increase here. English learners as well. And obviously a large reason for that is by making stuff visual at the start and enabling all students to get in and do the critical thinking and problem solving, and then adding the symbols and the visuals afterwards. It makes a lot of sense, and it means that it's something that can really change the nature of how they do things. So the good news with ST Math, you don't have to wait for state standardized tests to get data. Teachers do have access to real-time data as kids are working through. This is just a sort of dummy demo class type of thing. If a student is struggling, they're kind of stuck somewhere, the first thing the teacher will see will be an alert like this. They can click on it and go, the student has tried this level 10 times. They can click right from the report. They can click on this here and it will open up the exact game that the student is working on. They can have a Zoom call with that student, or if you've got a group of students who are sort of struggling in the same area, it will tell you where that is. The teacher can bring up that game. They can have that conversation. And we find that the most powerful sort of remediation if students are struggling in a piece of the course is the teacher actually getting the students to talk about what they're trying to do. In so many cases, that is the key to them. What's happening is, even when they're struggling, they're building schema, they're just not quite making the final connections. And then just having that conversation of getting them to explain what they were trying to do, and then the teacher going, well, have you thought about this? Or have you thought about that? Boom, they make the connection and away they go. This literally happened to my son the other day. He was playing something, got stuck. I didn't even really have to do much. I just kind of said, well, tell me what you're doing. And he went, got it. And away he went. So it's kind of a key piece. We've got tons of data here. I don't have time to go into it in a huge degree of depth, but you can look at objectives. You can see, how different students are moving through the course. You can dive in by student. You can look how, sort of how students are progressing overall. You can even dive in on a daily basis and see how many times each student has logged in on each day, all that kind of stuff. All of this data wraps up from the school level. A principal can look at sort of all the teachers and then dive down to student level. From a district level, you can see the schools, etc., etc., etc. So it sort of wraps up the way that you'd expect. And all this is live in real time as students are working through the program. Okay, so couple of last points, and then I'm going to turn it over to Sandra. One of the exciting things obviously here is students love this. They find this fun. This is actually highly engaging for them. We do have Gigi costumes and Gigi visits schools on occasion. Mercifully, I've never had to wear the Gigi costume because I'm 6'6", and a 6'6" penguin in an elementary school might be just a little bit terrifying for the kids. But kids love this. They find it exciting. They find it interesting. And we do, even though the kids don't know anything about the perception action cycle, they don't have to know about the perception action cycle, but we do see they get this idea of productive struggle. They get that by making mistakes that they are learning. So it does help them. It helps that conversation about, yeah, you can learn from mistakes. That doesn't become academic anymore. That becomes something they can see on a daily basis. Like, okay, when I'm struggling is actually when I'm really learning the most. So we see that they do kind of start to internalize that, which is exciting. And then something huge deal from last year, amazing piece of research. I've never seen anything like it on ST Math, and I've never seen on it any research like this on any other program either. It showed that by playing ST Math, just by kids playing this game with the penguin, it was changing their sort of self-belief, their self sort of positivity about mathematics. The idea that, by doing this, they were like, yeah, math, I love math. Math's my favorite subject. I'm a math person, because a lot of students are obviously going to get messages about math, whether we like it or not, that, you're not a math person. These types of people are not math people. And we can actually counteract that. We have research that shows that just by playing ST Math, it changed kids' self-perception of mathematics, and that change was strongest for the kids who had lowest achievement scores. So obviously the kids who already had high achievement scores, well, they probably already think about themselves as math people. But this was really very exciting and interesting piece of research. And one last little data point that I think speaks volumes about how powerful this can be in the current situation, because obviously this is a big deal. We've got a huge challenge here. Kids obviously have been out of the regular school situation for quite some time. So when COVID hit and obviously schools sort of shut their physical doors last March, we looked at over the next few months from that, sort of the average number of minutes that students were in the program. And we found that when schools shut down physically, the number of minutes that students spent on the program went up. So when they had a choice about what they could do, they actually played more ST Math than when they were at school the full time. So interesting data point. And I think it kind of speaks to kids like this. They will do this, and they will, they can enjoy it. And it makes a big, big, big change in the way that they can do math. So I'm going to leave it there. Obviously, we're going to have questions in a little bit, but I'm going to pass it over to Sandra. Sorry if I went a little bit long, I do apologize. And Sandra, we're going to talk with some people from Bay City ISD, I believe.
Jackie and Lisa, are y'all ready?
Sure
Yes,
thing.
awesome. Good afternoon. I'm Sandra Concilio. I am the program manager for this opportunity with Texas. I will be supporting your districts on a successful implementation, along with my team from ST Math and from Mind Research. I was a former administrator in Brazosport ISD, implementing this across the district in 10 of our elementary schools, 9 of which were in IR when we began working with ST Math. And the implementation of that, along with some blended learning and best practice research and instructional strategies, made a huge difference for our students. And then in turn, our teachers began to change their own instructional practice. And then we began seeing it across the campuses in other subject areas in our science labs. And in fact, that is where Lisa and Jackie had the opportunity to see that connection of what they were doing in ST Math being brought into their science lab. And we formed this partnership with them. And so You can hear my story and read my story on our website that we're going to share in a moment. But I wanted to take this opportunity to visit with Lisa and Jackie and hear their story since they've started with ST Math. So Lisa or Jackie, whoever wants to answer, just jump in. But we're going to start with, why did you feel that ST Math was the best program for your students when you began this year?
Sandra, thank you for this opportunity. You know, we visited your district to look at a whole different STEAM program and just happened upon ST Math while we were in your district for another reason. But one of the things that caught our attention, as Nigel mentioned, was the high student engagement. The engaging activities, the way students were engaged and talking to each other was just amazed me when we saw this program. And what we realized quickly, it was unlike any program we had seen. And it really changed our thinking from our teachers were really teaching the way they had been taught in a step-by-step, rote memorization, sequential way of teaching. And this really focused on students' understandings, on student thinking, on the critical thinking skills. And we were just amazed at the difference in this type of program.
So oh, go ahead, Jackie, sorry.
No, I was just also going to say, and it was interesting to see all the kids playing on it, and there was no language. So I noticed that, all the kids were engaged in it and no one was scared to try anything because there was nothing really to read. They were just, trying to figure out how to get Gigi across that screen.
Mm-hmm.
Jackie, I love that you said that they were not scared to try when they typically see math problems. Sometimes they're scared. And so I love that you mentioned
Right.
that they were not afraid to give it a try and to persevere through that.
Right.
What's been some of the most positive impact on students and teachers that you've seen so far?
Oh my God, goodness, just the excitement and the enjoyment of learning math. It's amazing to see them try and try again on different types of problems. And I heard one student say, hey, that was just like the problem I did on the puzzle yesterday. Mm-hmm. So it was interesting to see them, making those connections with, the other types of math problems that they had in class.
I agree 100% with Jackie. And I think from my perspective, this has been a capacity builder, not only for our students, but for our teachers. This was a little uncomfortable for teachers at first. They're very used to a traditional program where there's language, there's instructions. And so it really turned the tables and got our students thinking, put them in the driver's seat of thinking and learning. And teachers had to learn to become facilitators of learning. But it was so interesting to also see teachers discover how students were now analyzing their mistakes. It was almost a natural process. As students were not being successful and going through that productive struggle, you could hear the conversation between students about, well, this is what I needed to do. I should have done this. And so it sparked teachers even to be more of a facilitator instead of, I would say, a sage on the stage, a traditional teaching model.
Y'all bring up two good points. Lisa, you're right. It does make that change in the teachers and their instructional practice, that they see the students thinking differently and thinking deeper. And then you mentioned about the students who are presented with a puzzle and they don't understand what to do, and they just give it a try. It goes back to Jackie's comment of them not being afraid. They give it a try, they see the action play out on the screen, they're able to adjust their prediction based on that feedback and continue on. And so that's where they begin to see that success as well. Mm-hmm. So for anyone who's thinking about waiting until the fall to get started, why should they sign up now with their campuses? Why should they not wait until the fall?
One of the things I would say that we have learned by experience, first of all, ST Math was one of the easiest programs we've ever integrated into our curriculum. Yes. It integrated just seamlessly, both for our virtual learners, our on-campus learners, in just in a blended learning format. and there's so many uses for ST learning. We started out very basic, just using it for individualized practice every day. And as the students got the hang of it, as the teachers felt comfortable facilitating it, then we've expanded the use. We use it in math stations. We use it for individualized intervention, sometimes for small group. And then most recently, Sandra, you came out and we did just a little mini PD session on how to use it for direct demonstration, as a hook to your lesson. So I would say just jump in there, and the enthusiasm of the students and how they're engaged, it will spread like wildfire across your campus if you have just a couple of teachers who are willing to dip their toes in the water.
Right, very easy to implement. They can just dip their toes in it and let the kids go and explore and navigate their way through it. And you'll be surprised how many kids will figure things out so quickly. And then you can take that next step by, assigning different puzzles or, pushing them out to the kids. And then, you can take that big step with those math chats and those puzzle talks, by embedding those into their lessons. So very easy to implement.
And Jackie and Lisa, y'all have done an excellent job of implementing it this year. I know this is your first year on it, and you've already seen lots of gains and lots of successes and things to celebrate. Thank you both again for sharing your story. I know this was a really quick opportunity to share it, but we are so excited that you were able to come in and share with the rest of the educators that are on the line today with us. So how do you sign up? We've given you the information, you've heard the stories, now you're ready to sign up. So if you go to www.stmath.com/Texas, this is our landing page. As soon as you land there, you're going to see a button to sign up right where Nigel's there showing for you. Somebody's going to drop that link into the chat for you so you have access to it there as well. Once you get to our landing page, if you want to take a look at any of the games that Nigel shared with you today, the upright GG game, the GG cycle, click on play games and go in and play as a student would see, as the students would see it if they're playing these games. You have an opportunity to see some other games across grade levels as well. And then besides the testimony that you've heard from me and from Lisa and Jackie, there are other administrators across the state that are sharing their story and their successes. And you can take a look at those testimonials on our website and look through some other success stories that are posted there to share with you. And then, of course, we are TEKS aligned. So we have some correlations that we provided for you of what type of games do we have that correlate with the games that the students will see in the puzzles. And I know you have a lot of questions. There's some that are asked quite often. They're listed here on our page. There's additional ones. But we're going to take these last few minutes of our webinar today and our time with you to take a few Q&A that we've seen repeatedly in the Q&A channel. And if you have any additional ones, please feel free to go ahead and continue adding those and we'll jump into those. But I want to start with one that we saw earlier, and I kind of addressed it in the interview with Lisa and Jackie. But Nigel, do you want to speak briefly to what happens when a student doesn't know what to do? Is somebody going to come on and give them directions?
All right, fantastic. So yeah, great question. We get this a lot. In fact, I did a presentation just literally an hour ago where this was something that came up. Because it's, I think, Lisa, you talked about the fact that, so many teachers are used to how other programs work. There's almost this expectation that, well, if a student gets something wrong, shouldn't there be a page of text or a video or something that comes up and tells them how to do it? The big problem with that is that students actually do engage their perception action cycle, but they learn something we don't want them to learn when you do that. They learn that if they just click enough, it'll tell them the answer. And that's very self-defeating. They're not learning at that point. So we found that the most effective way of sort of that process really happening is, first of all, a student is going to make progress through ST Math, through the stuff that they get, and as they're learning and making, as they sort of master it, they'll make progress. If they're stuck, it's because we've identified the exact place where they're really struggling. And that is the best place for the teacher to be part of that intervention moment. So that's where then the teacher sees that kind of alert and can either individually or the whole class or as a small group, whatever it is, dive in, work with that student, and actually address those misconceptions. And we've just found that that's so much of a stronger method than this idea of like bringing up a page of text and so forth and so on, for a whole host of reasons, not the least of which that I'm sure you've all seen it with things. Students will just start clicking until they get told what to do. And that is not a great thing for them to learn. We want them to be engaged in that productive struggle. And we see it happening. It was so fascinating hearing Lisa and Jackie, you guys talking about, you walked into a room and saw kids using it. That's exactly what I did too. And once I saw that, I was like, whoa, something really different is happening here. So it's cool. It's exciting to see.
Nigel, the same thing happened with me. It was the students that sold me. It was the students that sold Jack
Right.
and Lisa too. And Andrew, do you want to clarify the opportunity for K-5 Texans?
Yeah, I'd love to. Thanks, Andrew. So as part of what we were able to work out with the ST Math team in between TEA and ST Math and Mind Research, what is available to all Texans is just the K-5 part of ST Math. So unfortunately, it's not the whole thing. ST Math has a pre-K all the way to 8th grade, essentially a group of products and programs for folks. We only have it through THL for free for y'all for K-5. That's not to say you can't use anything either above or below K-5, but it is to say that that will not be covered under Texas Home Learning. Other clarification is that this opportunity is available through December 2023. That's where we get the 3 years. It's 3 years from when the contract signed.
Garrett, do we have any others that have repeated quite often in the Q&A that we want to bring to the front for everybody in attendance?
Lots of questions about rostering, student accounts, teacher accounts, that sort of thing. So just to give it a real quick answer, we do support single sign-on through Clever and ClassLink, two of the most commonly used ones. We are also configured to support CSV roster uploads to create student accounts. We also have options if none of that works, and we have a visual password that students can learn and teachers can add them automatically with an invite code like they would with Kahoot. So whole bunch of different options. All of that will be outlined during the implementation planning meeting after you sign up at stmath.com/Texas. We will help figure out the best way to get your kids on.
I know we only have 2 minutes left. I want to be respectful of your time. We understand if you need to jump right at the top of the hour. Our ST Math team will stick around for just a few moments and continue to take your questions and get you those answers that you have. So anything, other questions, Garrett?
Let's see. Will we have access to the Q&A later? Yes, I believe, Andrew, we'll be able to publish all of these. We can export these, is that right?
The FAQ document, Latoya, if you actually go to the site that Sandra was showing, Sandra and Nigel were walking through earlier, go all the way to the bottom. It's access to the most frequently asked questions. And then you also have kind of another document there. Thanks, Nigel, for pulling it up to answer your questions. And then also that might not answer all of the questions. So actually that drop down at the bottom, you can reach out to the ST Math team. Garrett, I'm curious if there were other questions that you saw come across. I think one that I saw was related to professional learning opportunities. You mind giving us an overview of that?
Sure. So we've got a number of options again during the implementation planning meeting, the best time to figure out what's best for your district or schools. But we've got our larger scale TEA coordinated webinars. Those are going to be running several times a week starting next week for 90 minutes each session. That's going to get your teachers ready to start. We also have our self-guided online courses. Again, it takes about 90 minutes to complete those first two, and your teachers will be ready to go with students. So both of those will be really great options for once you have your account, you can take part in those. And we also have additional professional learning options available for purchase. Talk to your implementation manager during that implementation meeting.
Garrett, one other that I see coming across quite a bit is, I don't know if my entire district's going to sign up or is ready to sign up, or my school's ready to sign up. I would like to sign up.